Welcome to lesson 126, adding and subtracting fractions with unlike denominators. Our objectives today, I will be able to add unlike fractions and subtract unlike fractions. As always, we're going to start off this lesson with our vocabulary terms. From lesson 1 to 5, we learned that like fractions are fractions that have common denominators. Unlike fractions, so we can see from unlike would be the opposite of like. So unlike fractions would be fractions that have different denominators. And more often than not, this is what we see. So when we're looking at an addition problem, we would probably see numbers like 2/3 and 1/4. These are unlike fractions because they have different denominators. Equivalent fractions. In the word equivalent, we hear equal. So equivalent fractions, we can deduce that are fractions that are equal or have the same value. Now these fractions have the same value, but they are written with different numbers. So if you were to take 2 nickels and a dime, they're written two different ways, 1 dime or 2 nickels, but they're worth the same thing, so they are equivalent. So equivalent fractions would be like 2/4 and 1/2, because 2 out of 4 is half and 1 out of 2 is half. So these are equivalent fractions. Simplest form. So when we look at the word simplest, we know that that means easiest or sometimes even smallest. So when we look at simplest form, we know that this means when the numerator and denominator have only 1 as a common factor. Now this is kind of a difficult definition. So I like to tell students that simplest form is when a fraction can no longer be divided or made any smaller. It's in the smallest terms that it can possibly be, because the top and the bottom, the numerator and the denominator, have no more factors in common. So if I take 12/24, and I divide that by 2 over 2, that gives me 6/12, but this is not simplest form yet. So I can divide them both by 6, I see, and I get 1/2. So this fraction would be in simplest form because it can no longer be divided by the same number on top and on bottom. Least common denominator. So we talked before about least in common, and then the last word always telling us exactly what we're looking for. So with the word least, we know we're looking for the smallest of something. Common, we're looking for something that is the same, and denominator. So in this case, we're looking for the smallest same denominator. So the least common denominator is the LCM, the least common multiple, of 2 or more denominators. So for example, if I had 3/6 and 2/4, the LCM of 6 and 4 is 12. So 12 would be the least common denominator because we could change 6 into a 12 and we could change 4 into a 12. So really when you're talking about the least common denominator, you're really using the least common multiple to use as the least common denominator, because that's going to allow you to change these into like fractions, so that way we can actually add or subtract them. Alright, so I like to kind of compare adding and subtracting fractions with going to the grocery store and buying apples. So if you need to go to the grocery store and buy 10 apples, you're not going to grab 5 apples and 5 oranges, because that doesn't give you 10 apples. You can't add 2 different things together to make a whole group. of one thing. So you can't go to the store and buy 5 apples and 5 oranges to get your 10 apples. You would actually have to buy 10 apples. You have to have the same thing. It's the same idea with fractions. You have to have the same type of fraction or the same size pieces in order to add or subtract any fractions. So we talked about adding and subtracting like fractions. We can do that because the pieces or the denominators were all the same. Whereas in this case, if you look at the last problem, we have 4/5 plus 3/4. Well, since these pieces aren't the same size, we can't add them together correctly until they are. So again, if we take a look at 4/5, so 1, 2, 3, 4, so those are the size of fifths, plus 3/4. Well, these aren't the same size. So when things aren't the same size, you can't add them together and get an accurate answer. You can only add apples to apples. You can only add fifths plus fifths, 6 plus 6, tenths plus tenths. Right, so your different steps for being able to add unlike fractions, and don't forget these are all written right here. So I written out the steps for you, and all I want you to do is show the work for each step underneath. So the first thing you have to do is find the LCM of the two denominators. When you find the LCM of the two denominators, this will be their least common denominator. So in this case, I have 4 and I have 5. I'm going to use the ladder method because I like to use the ladder method. I think it's a little bit easier. I know that 4 and 5 only have a common factor of 1. 4 divided by 1 is 4. 5 divided by 1 is 5. And since 1 was on the outside here, I know that I have to keep these on the outside. And because it's the LCM, I multiply everything together inside of the L. Okay, I can ignore the 1 because 1 times anything is just going to give us the number itself. So I can do 4 times 5, which gives me 20. So the LCM of 4 and 5 is 20. So that means my denominator is going to have to change to 20 because it is the smallest number that 4 and 5 have in common. Alright, so now we're going to use that least common multiple to make two equivalent fractions with a common denominator of 20. Now the reason that we want to use the least common denominator is because sometimes that allows us to not have to simplify, and also it makes it so we don't work with huge numbers. I know a lot of times students like to just multiply the two denominators together and use that. However, sometimes that can give you a very large denominator, and I like to work with numbers that are small. They're easier to work with because they're not that large and there's not that much that you have to do in order to manipulate them. So in this case I have to think, what do I do to 4 to get to 20? When we're making equivalent fractions, the only way you can do that is to multiply or divide. And in this case, since we're trying to go from 4 to 20, I know I have to multiply because multiplying is the only thing that makes my numbers larger. Also, it would help to remember that since we look for the least common multiple, and this is a multiple of 4, it would make sense that we have to multiply to get to it. So I know that in order to get from 4 to 20, I have to multiply by 5. And we talked about the golden rule of algebra. It's what you do to one side, you do to the other. And we can also transfer that to what you do to the bottom, you have to do to the top. So since I multiplied by 5 on the bottom, I also have to multiply by 5 on the top. So I'm not multiplying by 5, I'm multiplying by 5/5. It's very important to understand that there is a big difference here because if you just multiply by 5, you'd actually end up with a different answer. So I need you to make sure to get used to saying that in order to make an equivalent fraction, you had to multiply 3/4 by 5/5 or 4/4, whatever this fraction here ends up being. So now I multiply 3 times 5 and I get 15. And then I have to do the same on the bottom. So in this case, I'm going from 5 to 20. I know that I have to multiply by 4. I know that what I do to the bottom, I have to do to the top. So I'm going to multiply 4 times 4, and that gives me 16. The third step is to add or subtract the equivalent fractions. So now instead of having 3/4 plus 4/5, I have 15/20 plus 16/20. Now I have apples and apples. So what I'm going to do is I'm going to add my numerators just like I did when I had like fractions, because now I have like fractions, and this is 31 over 20. Now the last step is always to simplify, and this also means to change the improper fraction to a mixed number if you end up getting an improper fraction. In this case, we did get an improper fraction, so I have to divide, and I have 31 pieces and I want 20 pieces in each group, so I'm going to divide 31 by 20. 20 goes into 31 once, minus 20 gives me 11. So I know that I made one whole group, I had 11 pieces left over, and I put 20 pieces in each group. So my answer to 3/4 plus 4/5 is 1 and 11/20. Alright, so I'm going to do another example with you. I want you to make sure to write this all into your notes. Okay, you do have this right here. And then I will give you an opportunity to practice on your own, and then you'll be able to come back and check your answers. So in this case, again, I have to find the LCM. This time it is of 2 and 5. So I put 2 and 5 in my ladder. I know 1 is the only common factor. I get 2 and 5. 2 times 5 gives me 10. So I know that I have to somehow get my fraction to have a denominator of 10. So up here, I'm going to multiply, well, 2 times 5 will give me 10. So I have to multiply by 5 on the top. 1 times 5 gives me 5, which makes sense because 1/2, well, 5 is 1/2 of 10, so having 5 out of 10 would be half. Now in this case, to go from 5 to 10, I multiply by 2, so I have to multiply by 2 on the top, so I get 4/10. And now I subtract like I normally would because it is still a subtraction problem, and I get 1/10. And we can check behind our apple here to see if we got the correct answer. And we did. Alright, so now I would like you to try this problem on your own, and when you come back, we'll go over your answer. Alright, so the LCM in this case of 3 and 10 would be 30. In order to go from 3 to 30, I'd have to multiply by 10 on the bottom. So I have to multiply by 10 on the top, and I get 10/30. In order to go from 10 to 30, I have to multiply by 3. So I have to multiply by 3 on the top, and I get 21/30. I add, now that I have like fractions, I can add, and I get 31/30. And this one should be fairly easy, so I'm not going to write out the division. I'm okay with that because I know I have 31 pieces and I can put 30 in a group, so I can only make one full group. I'd have one left over and I'd still have a denominator of 30. So my answer in this case should have been 1 and 1/30. Hey, if you didn't get that correct, I want you to make sure to check this work and see where your mistake might have been, and make sure to keep trying. This is a tricky thing to do, but once you get the hang of it, it gets a lot easier. Alright, so I have 4 problems here for you that are listed in your workbook. I want you to try those problems on your own. Okay, and then I also have a word problem for you that I would like you to try. Phil made a pie for his basketball team's spaghetti dinner. Tommy said he ate 5/8 of the pie, and Chucky said he ate 3/12 of the pie. Is this possible? If so, how much of the pie was left? So this is a two-part question. I want to know, number one, is it possible? And then second, how much was left if it was possible? So for this problem, you are going to have to solve it, and we will go over your answer in class. However, the rest of these will be posted on Edmodo in your quiz. So if you have any questions, please make sure to post them to Edmodo so we can go over them in class.